Let's talk about algebraic properties of equality. These properties are things that you have already done, you already know how to do it, but now we're just putting a name to it. So earlier I was talking about balance and how algebra is balancing both sides of your equation. Well, the addition property of equality, this guy right here, states that if A equals B, then A plus C equals B plus C. So this is basically saying to maintain the balance of both sides of our equation, whatever we add to one side, we also have to add to the other. So you might see this when you're working through an equation like this, possibly. Let's see. I'm going to just make up something. I'm going to say 8x minus 1 equals 7. All right. So when you're working through a problem like this, you'll probably add a 1 to both sides, and that's just called the addition property of equality. All right. The next type of property of equality, or POE, is subtraction. And this one is very similar to addition. It's saying that if A equals B, then whatever we subtract from the left side, we also have to subtract from the other side, and this should say equals B minus C. Alright, so we might see this if we were solving an equation and it looks something like this, and our first step with solving this would be to subtract a 1 from both sides. So that's called subtraction property of equality. The next one, multiplication, very similar to the others. It's saying if A equals B, then A times C equals B times C. So basically it's saying if we multiply on one side, we also have to multiply on the other side to maintain the balance. So you might see this in a problem that has, I don't know, maybe it has 1/2 times x equals 3. All right. So in a problem like this, you would start off by multiplying both sides by 2, and then your next step would be this stuff, and that's called multiplication property of equality when you multiply on both sides. The next one is called division property of equality, and similar to the others, it's saying if you divide on one side, you also have to divide on the other side. So we might see this in a problem like this, where in order to solve for x, our next step would be to divide both sides by an 8, and then we would just continue from there. We'd have x equals 2, and we keep on going. All right, and then the last property of equality on this slide is the distributed property of equality, and this states that A times B plus C is equal to AB plus AC. So that one's pretty self-explanatory. So if we have like 4 times x plus 2, then that's going to be equal to 4x plus 8. All right, I'm going to go to the next slide. The next property of equality is reflexive property of equality. And this states that if we have a value, and let's just call that value A, then A is equal to A. So that value is equal to itself. So an example would just be 4 equals 4. All right, that's pretty much it for reflexive property of equality. The symmetric property of equality states that if A equals B, then B equals A. So notice in the original statement, what they did to go from here to here is they just swapped B and A, and that's called symmetric property of equality. So you might see this in a proof where it has a previous step of x equals, let me actually change that. It'll have a previous step of 6 equals x maybe. And then what you're going to do is you might change it to x equals 6 because you like that better, or either that's what it ends with for you to prove. All right, so that's called symmetric property of equality. The next one is called transitive property of equality, and this states that if A equals B and B equals C, then A equals C. All right, so basically it's saying these three components or these three variables are all equivalent to each other. So we're just swapping them around. We're saying this is the same as this, so these guys have to be equal to each other. All right, you're going to see transitive property of equality once we get to our geometry proofs, but right now we're only doing algebraic proofs, but I can give you an example of something you might see in an algebraic proof. So you might see x equals 8, and then you might also say, well, 8 is also equal to y. And then you could end it with therefore, since x equals 8 and 8 equals y, then x is equal to y. And this is called the transitive property of equality. You're always going to have 3 or more variables or values that are equal to each other. Substitution property of equality states that if a equals b, then b can replace a in any expression. Or the reverse way, A can replace B in any expression. And that's it, guys.